Bismillahirrahmanirrahim. Today's topic is a function, and one's point is the one-to-one concept. A very important concept. So it decides that function it has inverse or not. Okay. So if function is one-to-one function, it has inverse, and if not one-to-one function, inverse does not exist. This is the whole story. So let's start. Bismillahirrahmanirrahim. What is one-to-one? Let me explain the logic behind it. What is the logic? Okay, concentrate please. This is a form equation given here, y equal x plus 1, and if you look at carefully, this is a drawing, okay, and if I ask you what is x1, what is y, you can go check, the answer is coming 2. If you go here, it's coming 2. It means I am putting this D for domain and this R for range. I put 1 and I'm getting 2. This is called domain, this is called range. What you put inside is called domain, and when you get from there is called range. Or short thing I said you last time, x is called domain, y is called range. I put now, for example, 2. When I put 2, and I'm getting 3 answer. So when I put 2, I'm getting 3 answer. So it is very clear. So this is a domain, and this 3 is called range. Okay. This is for function. This is for function. Now, what happened? You done in O levels even the inverse concept. In inverse concept, what happens? X become y and y becomes x. This is interchanging the variables. It's called inverse. You have done. So when I talk about F inverse concept, F inverse. So what happens then? This becomes domain and this become range. So it means this 2 domain range is 1, 3 domain range is 2. And we check even if this was x and the y, and what interchange. So this becomes y and this becomes x. You can see now against 3 I'm getting 1. So you can see that while going from left to right, I have one value of x, one value of y. Coming backward, one x value, one value of y. It is called one-to-one idea. What is called? One-to-one. Example, there are 3 people standing here, 1, 2, 3, and here 2. It is called one-to-one? No way. But if we have a 3 people here, like this is called one-to-one sitting, one-to-one, front of each other, right? This is called one-to-one. So it means in function, 2 values of x, 2 values of y. Coming backward, 2x values of 2y values. So it means both I end function and backward. So we have one-to-one concept is there. So when we have this rule is applicable, that while going this way or backward, with every one x has one value of y is called one-to-one. I can say that all linear functions are one-to-one. One-to-one. And if they are one-to-one, so they have inverses. So they have inverses. Okay, it means inverse exists for it. Okay, come to this question. This question is a little different than that one. Okay, I have drawn the diagram. Okay, graph is sketched here. So we can see here x squared plus 1, it's cutting at 1. Okay, now check what happens. For example, D for domain and R for range. So I put 1, when I put 1 in the place of x, so I get 2. When I put minus 1 in the place of this one, when I put minus 1 to power 2 plus 1, I get again 2. So against minus 1, I'm getting again 2. Again 2 means I can make this arrow. Okay. So against 2, if I check for 2, so 2 give you 4, and minus 2 give you also 4. So you can see here that here we have one x value, one value of y. One x value, one x value of y. One x value, one value of y. Correct. But when I go backward means for inverse situation. What happens? This becomes range and this becomes domain. So when I have this domain, let's see what happens then. So this 2 has 2 answers. One answer is 1 and one answer is minus 1. This 4 has 2 answers. One is 2 and one is minus 2, which is against the rule of the definition. What is the definition? Like I give an easy example to understand. Little funny, but easy to understand. One man can marry one lady at a time. He cannot marry. He can marry after 2 minutes, after 10 minutes, after 1 day, after 1 month, 1 year. But same time he cannot marry two ladies. Because nikah, whenever nikah is start with one lady, one man. So it means I'm saying one x value must have one value of y. If we have one x values, two values of y, against the rule. Against the rule. So rule is violated here. How rule is violated here? Because one x value has two values of y is wrong. So while going this way, rule is fulfilled. While coming backward, rule is violated. It means this function is, so it means quadratic function. Quadratic function. By default, not one-to-one function. Not one-to-one function. So they don't have inverse. So they don't have inverse. But we have one method. You know what is method? What? If you want to make one-to-one possibility, so simple story we have. Either you take left half curve or right half curve. Example I give you. If I rub the first one, so look the way. If I take this curve, so let's see what happens. So from here, if x is going bigger than 0, if I draw my graph, start from 0 and move forward. So is it one-to-one function? Yes, it's a one-to-one function. How come, sir? Look here. For L, okay, look here. I can even give an idea here even. So look, against this 2, this is a 2. I have a 1 value is coming here and 1 value is coming here. You see? So it means when I draw a line here, it has two answers. But when I make a line here, for example 2, I am getting only one answer. I'm not getting two answers. Here I'm getting two answers. So it means when you go for this question, if you go function or you come backward inverse function, so it is one both hand. I can give an idea here. For example, if you look at carefully, while going from here to here, 1, I'm getting two answer. Against 0, I'm getting one answer. This is called domain and range. But when I go backward, this is for function. This is for function. When I go backward means this domain and this range. So against 2, I'm getting 1. Against 1, I'm getting 0. It means it's very clear that this situation inverse is possible. So it means you learn one lesson from here. If your curve turns from turning point, so it has no inverse. So it means you have to stop your graph at turning point. If you stop your graph, left side graph comes, and stop graph here, it has inverse. Or if you plot after, so it means short story, I can see here one thing, this graph, if I graph start from here and stop, it means my x value start from 0 and backward. So inverse exists. Inverse exists. Or second option, if my graph start from 0 and move forward, so from here backward, so x is bigger than, so inverse exists. It means one part of graph, if I have it, before, after turning point. I have to stop my graph at turning point. This is a rule. It is inverse possible. Otherwise inverse not possible. Now I think so. My question from you, if you are coming from the left hand, from right hand side, right? For example, you are coming from here, from this end. My question, where you have to stop, so inverse exists. Let's see. I have 2, I have this value. 1, I have this value. I'm coming from this end, continue, I have to stop here. Right or not? So what is the least value? So inverse exists. I'm writing here. What is the least value? So inverse exists. So inverse exists. So what is the answer? Here is 0. So I have to stop at x is equal to 0. So, and my question, now if I come from this end, so what is the largest value? What is the largest value so that inverse exists? So inverse exists. So naturally x is again 0. So it means if I give an extra example, for example, your turning point is this. Turning point, x is 2, y is 5. X is 2, y 5. My question, what is the least value if I'm coming from this end? What is my least value so inverse exists? So answer is 2. Okay, if I come from this end, what is largest value so inverse exists? X is 2. It means you have to stop your graph where? At a turning point. And that's enough.